So today I want to show you an application I built called Tycho. Tycho is a graphical user interface for monitoring launch vehicle and spacecraft data. The main technologies used are AngularJS, CSS and Sass, and then the Three.js WebGL library for our 3D graphics. On the back end, the server is built in Express, and I'm using a MySQL database. So let's go ahead and get started. So the main idea behind this project is that mission controllers need to view the data that is critical to them in a logical and intuitive format. I think when engineers are presented with clutter and an overload of data, it has the effect of clouding their judgment. So the first page here is going to be a mission overview page. And at a glance, this will show you all of the most critical data about the current mission. So let's go ahead and start at the top left. Here we're just going to show some metadata and stats, like heading, velocity, altitude, and a few different mission clocks. If we go down to the bottom left, this is going to be a trajectory overview for the current mission. So here we're going to show our current trajectory in white and our target trajectory in blue. If we move to the right, we have an image of the Falcon 9. This will just reflect whatever launch vehicle we're using for the current mission. If we move on even more to the right, we have a breakdown for stage 1 and stage 2. So we know stage 1 has 2 fuel tanks and 9 engines, so we want to show the critical data for both those tanks and engines. Similarly, if you go up, for stage 2 we have 2 tanks and 1 engine, and we want to show the same critical data. Okay, so now I want to show you the first subview, and that is going to be the trajectory overview. So essentially this is going to be an enlarged version of the graphic I showed you on the first page. If you look to the right, we show a number of data points about our orbit. So we show apogee, perigee, and inclination, and then we show the same values for our target apogee and target perigee. So the way this works is that we're going to do a fetch from our database, and it's going to send us back the current telemetry data. When we receive that data, we then render our Three.js graphic using that telemetry data. So essentially, over time, as we fetch from the database, our graphic will re-render to reflect the new state of the orbit. Okay, so the next thing I want to show you is going to be the engines overview. So for this, I'm going to show 10 engines, 9 for stage 1 and 1 for stage 2. So the main stats I want to show are the chamber pressure, the force of thrust, the nozzle temperature, and the turbopump speed. So now I want to show you a bit of a simulation. So to do this, I'm going to run a database seed file. So what this is going to do is it's going to seed my database and then update its values programmatically. Now if we jump back to the front end, we're going to see that these values are going to increment over time. And the main purpose of this is to demonstrate how a warning system works. So we'll look at engine 3, and we see that as the chamber pressure exceeds 9.7, we're going to throw a warning. So showing the controllers visually what exactly is wrong based on the predefined threshold that we've set. You can see how these thresholds can become more complex and more robust for different data points we look at. Okay, the next thing I want to show you guys is the fuel tanks overview. So we have 2 fuel tanks, so we have liquid oxygen and kerosene, both for stage 1 and stage 2. And we want to show the critical data about those tanks. So we're going to show an overall status, remaining volume of fuel, an average fuel temperature, tank pressure, and then on the right-hand side we're going to show, is our intake and our outtake, are they closed? The pressure or the status of our internal helium bottles, and the last thing is going to be the external pump status. And this graphic, as our fuel decrements over time, the graphic itself will reflect that depleted fuel. Okay, so the last thing I want to show you today is the actual spacecraft overview. So this could be a satellite, an arbitrary payload, or the Dragon. I chose the Dragon for this case. So first we're going to show an image of the current payload, the Dragon, and then to the right we're going to show the current trajectory of the Dragon. If we zoom down to the bottom, we have 2 panels, one for life support and one for power systems. So for life support, we want to monitor the internal conditions of our spacecraft. So we're going to monitor the atmospheric pressure, the oxygen levels, the carbon dioxide levels, And then at the bottom, we want to know our O2 storage and our water storage. On the right-hand side, we want to keep track of our total stored power in our batteries. And then we want to know how each of the solar panel systems is working. So we're going to keep track of the production and orientation of each. Lastly, on the right-hand side, we're going to give a breakdown of the propulsion and fuel systems. So we're going to give a detailed breakdown for our RCS Draco engines and our Super Draco main engines. And beneath that, we're going to show some details about the fuel tanks for each of those systems. So this is the extent of what I wanted to show you today. But you can see how this could be tailored and expanded, how we could add more views for different mission controllers and tailor it very specifically to the needs of each person. I think these principles can be applied to both an application in mission control and also to applications used in managing manufacturing operations. Thank you for watching, and I hope you enjoyed.